VP is a Swiss Army knife for conducting covert communications, network administration, and secure data storage. Allowing users to hide reverse shells and file transfers among regular traffic, a real-world use case for VP is testing your SOC's ability to detect malicious traffic patterns. VP has 4 levels of encryption: base64 encoding by default, base64 encoding wrapped in TLS version 1.3, VPP, discussed shortly, and VPP wrapped in TLS version 1.3. Client and server operations feature stable reverse shells, file transfers, and chat rooms. There's 24 host variations relative to the different levels of encryption. You can also use VP to encrypt or decrypt files, directories, or paths, or generate any of the necessary cryptographic credentials for its operations on the fly. The program uses a SQL database to store remote public keys for authentication and the connection information and credentials for remote servers. VPP, the Virtual Privacy Security Protocol, uses hybrid encryption, has RSA signature verification built into every message, and secure authentication mechanisms to prevent unwanted remote access to a device, file, or chat session. Before creating a VPP encrypted connection, users need to exchange RSA public keys. Using the command at the bottom of the screen, the server admin registers the remote client's RSA public key in the runtime SQL database, and the client connects to the server. After authentication, further communications are encrypted with VPP. Under the hood, authentication is a little bit more complicated. To keep this presentation engaging, I'm going to jump into the demos and not cover this in more depth, but I do encourage any interested parties to pause and review these slides or check out the extensive documentation on the GitHub repo. I'll start by generating the necessary credentials for the 4 levels of encryption. Here I'm creating an RSA key pair to establish VPP. Now I'm self-signing an X509 certificate with the RSA private key that I just created. Now I'm creating a new RSA private key and a self-signed certificate for immediately establishing an SSL connection. Now I'm adding an RSA private key to the SQL database for authentication. Now a remote server's connection info. Okay, here I'm establishing a reverse shell. The client's parent directory on the top left contains the file zenofpy.txt. On the right, you can see the file does not exist in the server's parent directory. The reverse shell is established. Now the server can see zenofpy.txt. I'm going to take a look at the TCP stream in Wireshark. I'm going to decode the last transmission with a simple Python script. And we can see the Zen of Python. Next, we'll look at level 2 SSL encryption in Wireshark. We can see TLS version 1.3. Next, we'll look at level 3 VPP encryption using the program's file transfer operation. Verbose information about the authentication process is printed out, and we can see that the file was downloaded successfully. In red, you can see the authentication process, and in blue, the file. Finally, we will look at level 4, VPP wrapped in SSL. This is a chat room server that 3 clients are connecting to. After authentication, whenever a client sends a message to the server, it is encrypted from end to end with VPP and TLS version 1.3. Messages are broadcast to every other connected client, each encrypted using VPP and the respective recipient's RSA public key. Let's check out the chat server in Wireshark. We can see again TLS version 1.3. Now I'll demonstrate VP's encryption and decryption operations. On the bottom left, you can see the directory tree for the secret library in VP's parent folder. You can see here that I have the Art of War. I've encrypted the file. We can see the VPP ciphertext. That's the wrap session key at the top. RSA signature authentication is optional for this process. I've successfully decrypted the file. Now we will encrypt a directory. This operation won't encrypt any files within nested subdirectories. Finally, we'll encrypt entire path recursively. That's it for the demonstration. I hope you have fun with VP.